Hi everyone, and welcome to this session with TechMinds. With us today is Frederic Gendebien. He is a solution architect and has been working for several organizations. And the topic for today is key lessons learned from an experienced solution architect. So, welcome, Frederic.
Hello, Stefan. Thank you. Thank you very much. Thank you for the invite.
Yeah, great to have you here. So Frederic and myself, we've been colleagues, so we know each other quite a bit. But for everyone else here, maybe you can do a bit of an introduction, Fred?
Yeah, sure. How can I say? How can I start? I'm in the IT business for like more than 15 years now. I started as a Java developer, then Scala, then moved to the architecture like 10 years ago. And I fell in love with secure and event sourcing and even modeling. And that's in this context that we were colleagues, actually. I'm actually still an architect. I became a Go developer like 6 years ago or so, and I fell in love with the language. So now I'm helping companies with Go development, of course, using secure and event sourcing in a nutshell.
Cool. And what organization are you now mainly spending your time on? Like, can you mention the project you're currently working on?
It's actually a project which is not live, so I cannot speak about it, unfortunately. But the business is very interesting. It's in the car. It's a car business where you can reprogram the computers in the car, and that's all I can say.
Very interesting. Okay, well,
Yeah.
I will not bother you and poke the bear a bit there. So let's move on to some of the other questions. So a question I have is, can you explain the role of a solution architect in a data-driven organization? How do you, for instance, collaborate with data analysts, but also other team members to design effective solutions?
That's a broad question. I try to use modern techniques for that. So I usually go into a company and they say that we are following this principle of this way of designing. But I try to just get through the most interesting technique, which is event modeling. And now I'm trying to impose event modeling, not because it's cool and hype, it's because it's very efficient and very easy. Everybody can understand it. Even the business guy who has no idea about IT, it can follow with just sticky notes, and we just speak business terms, and we use sticky notes, and that's for me the best way to enter the company and to understand actually the business. It actually depends. How is the maturity of the company? I usually start with event modeling. If they're not mature enough, I try event storming. It's another technique, and it's more for understanding the business. And event modeling is more like if you are mature enough, you start with brainstorming a bit with the event, and you put the relation between user experience and system design in a very, very simple way for everybody. And then you have to explain, of course, event modeling related to events, but we need to explain a bit to everyone, especially the data analysts, what it means, data. Because most of them think that data is in a relational database. And I hate this. I really hate that. So I have to break their mind and say, no, data is not in a relational database. Data is actually your messages and precisely your events. So it's a real big fight at the beginning. And when they see the light, it becomes very easy. So what I expect from data analysts after they finally understood what is data is to shape the events. That's it.
Cool.
So
and your role in this is more as the orchestrator, right? So you bring together these insights and the people to make sense of data.
I also validate the model, like because I'm asking them to shape the events, but of course I validate because shaping events is really, really interesting. You know that, Stefana, you remember those days. And if you screw this, you're really, it's over. So when they shaping events, we are doing like brainstorming session to review session, I should say, to say, okay, this one is not good enough because it's too big. This event could be split and into multiple events with more meaning. And so I review, actually. I review. And if they have a solution for the store, I use a solution. I'm probably one of the administrator, but if they don't, I actually create the store from any database that they have. So I also design the store. That's what I do. Yeah.
Cool. The second question that I have is looking ahead. What emerging trends or technologies do you see influencing the role of data analysts, but also of solution architects in the next few years? And how should aspiring professionals prepare for these changes?
It's a good question. I don't want to say any data analyst technology which is on the market because those are probably driven by the database itself, and this is something I really don't like. But I would say more about techniques like even modeling now is really exploding. It was a very nice, let's say, technique for niche customers, but now it's taking a huge, it's really exploding. And this techniques is, for me, is the future of system design, especially in event-driven systems. And for technologies, I think it will be surprising, but Postgres became a very nice store against everything that we knew from AxonIQ, if I can say. But Postgres now with a lot of plugins and very specific configuration is a very nice alternative to many stores on the market. So don't underestimate Postgres. That's.
And for newcomers to this world, like how would you, what kind of advice would you give them to start focusing on?
I would say try to create the store yourself. Fail, and then learn from the failure. Of course, start with the theory, but don't be afraid to create a store by yourself. Because a lot of people out there, they're saying, well, please don't do that. You will lose your time, you will fail. You will probably fail, but you will never lose time. You will understand the concept much better. And actually a store, if you use something like a Postgres or any database, is not so complex. The scaling up is complex, and that's what we learned with AxonIQ. Yeah? But the concept is not so complex. So don't be afraid. Do it yourself. That's the best tip I can give.
Good. Yeah. Yeah, and it fits your character as well, right? So for some, it might be a bit overwhelming or a bit scary in a way, but yeah, you have to get through it, I guess, in order to learn from it. Yeah.
That's the best way I learned even sourcing, actually, is when I created my first store. I thought I was like, okay, I know that thing, but no, actually, no, I don't know. And it's really when you do it that you understand.
Great. And the third question: what do you do as a solution architect in a regular week?
Basically, shaping up the store and reviewing the model. And of course, so I need to understand the business. I need to understand what they want to do, shaping the solution architect. But from a technical perspective, it's quite obvious. So we use the technology of the clouds, and we select the technology of the clouds which we see fit for the solution. and also for their cloud account. Sometimes you have a perfect solution for their problems, but they don't want to use it. So you have to cope with your customer, right? So yeah, selecting the right technologies, shaping up the even model, and orchestrating the meetings with everyone to understand the business and to design the systems. That's what I do, and I develop, of course, because I will never stop developing. You know me.
And is there a particular split? Like how many hours a week are you able to develop, and how many hours are you more involved with with modeling and reviewing?
It depends the project. In the beginning, it's really a lot of discussion and a lot of modeling. Of course, you start by what do we want to do. Modeling can hold for a week, and when we have it, it's time for development, right? So now I'm in the middle of the project. I know we started like 3 weeks ago. I'm developing almost 100%. We chose everything. We chose the technology stack. We have the model, so we are ready, and I just develop. So still, I don't develop only the business features. I also develop the framework so that other people can use the tool a very easy way. So even if they don't understand the foundation of even sourcing, they can use the tool. That's and I'm also responsible for this.
Good.
So I still develop a lot.
Yeah, I think it goes hand in hand, right? You cannot really stop developing and just only focus on the architecture side of things. Then you will probably put yourself in some sort of an ivory tower, I guess.
You can do it, but you will become a very bad architect, in my words. Yeah.
So a fourth question that I wrote down is: what challenges have you encountered in cross-functional teams when implementing CQRS and event sourcing?
Oh, that's a human problem. The biggest challenge you encounter when you try to help people is they don't want to be helped. That looks completely silly. I assumed too much. When I am learning some new stuff, I'm really excited, and if there is something I can improve, I just do it. And I assume people are like this, but it's not true. Not everybody wants to learn. Not everybody wants to improve. So yeah, that's the biggest challenge: changing the mentality of people. Say, I never did CQRS, I never did even sourcing, and I will not even start. Okay, so you know what it is? No, and I don't want to know. I mean, it's a big shock. Like, you're not even curious what it is. No. I work with a database. I put data in a database. I retrieve it, and I'm happy. So the biggest challenge is to convince people that learning is something we have to do as computer scientists. We should always learn new stuff just to optimize what we were doing. Sometimes you learn new stuff, you learn new technologies, new languages, but actually it's not good. It happens. Security and even sourcing were actually the best things I learned in my career. It really shaped my present, and it will shape my future probably. But it happened just because I was curious. I had a problem. I needed a solution, and it was a very complex problem. And we just read and say, okay, it looks like a good fit. It looked super complex. I say, but let's dig into this and split it into very simple stuff. So don't assume people wants to learn. They don't. And yeah, that's the biggest challenge. Nothing from a technology perspective, just human.
Interesting. Yeah.
Yeah.
Cool. Yeah, I have a final question already. So I think we're doing great. Hopefully the questions are interesting. So the last one is: what are some common performance pitfalls in Go or Kotlin that developers should be aware of, and how do you mitigate them?
I don't do Kotlin that much these days. The Kotlin part is very easy, actually. You're still using a JVM if you're using Kotlin. Now with the new Spring native and all these things, you can run from you can create a binary program. That's very interesting. But the setup was so complex in the past that I almost gave up. Now apparently it's easier, and if it works, please consider using native compilation, because the JVM nowadays, it doesn't make sense. When we create application, where do we run it? As system designers and backend developers, we run them into the cloud, into a container. A container is already something on top of a operating system of a host, which is usually Linux. So having a JVM that was designed to run any programs anywhere doesn't make sense anymore in the world we live in. So drop the JVM. That's for Kotlin. And for Go, actually, I love Go. I never had any problem with Go. Probably, yeah, there were some pitfalls with some part of the languages, but it has been actually resolved from the very last version of Go. And don't be afraid of the channels and the coroutine, the paradigm. Just learn them. It looks very complex because we don't know that when we start computer science, but actually those concepts are very old. From the 60s or 70s, if I'm not mistaken. So it's very, very old. But in those days, they were inventing stuff very easily and very easy. So they came up with solutions that when I look at Go, I was like, oh my God, I remember that theory. I learned that at university, and I remember it was from a very old guy. He created very nice stuff that nobody understood. But it was actually easy. And Go, I really like the language because it took back those initial ideas and bring them back to now, actually. And don't underestimate the memory management of Go. That's the only thing, because sometimes if you really need some performance throughput, it can hit you in the face. But it's very, very specific use cases. So, and again, don't be afraid. Try Go, use Go. Try even to create a service in Go in your distributed system. Your client will be happy.
And how do you involve the client as such, and how do you mitigate these risks? Is that mainly about working together in a team and exploring and understanding what it can bring?
Yeah, when I bring Go into a new company or just a new customer for me, I'm actually asking questions like, are you happy with the performance? Are you happy with the way you develop? Are you happy with the time to market? And most of the time they say no, 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 no. So okay, what's going on? Say yeah, we have tons of developers, of Java developers, and mainly Java, but the quality is not good. Say okay, so we should either you try to screen better developers, and you take a lot of time to screen better developers, or you actually remove Java from the equation and say try other languages, because the people you will find for those languages will be actually better than the bad Java developers. So let's try a new language. And of course, we have to also say, don't take a new language just for fun, but what is the system you're trying to build? Do you know where you want to run? Is it in the cloud or on premises? Is it homogeneous or not? So that means, do you know that it will be only Linux, for instance? So yes, okay, go for Docker, go for binary languages such as Rust or Go. And when by discussing and finding the pain points that they have, usually you end up with the same principles. Like, okay, go easy, remove all the unbearable things we have with old languages, like the management of the environment, like the setup. I remember when we had to set up just a project, it took like hours at best. Now, if I want to do the setup, it takes 2 seconds. I just type, go mod init, and I have it. So easy. You see, that's those simplification. The client is happy with that because it says, okay, it goes faster. The language is simpler. The developers, not so many developers, but if you find a developer, you know that it's actually above average already. And with everything that I just said, the client would be a bit silly to say no. And if the system is quite distributed, you can say, let's just create a small service. You need new services. Let's try to use Rust or Go, and let's try to implement that very simplistic service with that language and see how many days or hours it took me to do that. And usually the difference is huge. It took, like I remember, for one customer, even to run the solution, the existing solution, just to run it, right? Locally, it took like 2 hours just to run it. And I was like, what the hell? Yeah, probably the most complex environment that I encountered in my career. And then I arrive with a simple Go connected to G-Cloud and I say, look, if I want to run it, it takes 5 seconds. And that's how it should be. Imagine 2 hours, 5 seconds. The customers, which is not IT oriented, says, what the hell? just use that. So yeah, just try and show. Not too much talk, but demonstrate that those languages were actually designed for the modern world.
Great.
Yeah,
I think that's an amazing conclusion as well, Frederic. So happy to have you here with the TechMinds team, and thank you on behalf of the entire team for being with us.
Thank you for the invite.
Yeah, you're more than welcome. Good luck, and hope to catch up with you very soon.
Thank you.
Okay.
Have fun. Bye.
Bye.